Good morning, everyone. Let me mute. Okay. How are you doing? I hope.
Good morning, Professor.
Oh, hey, good morning. Oh, good. I can hear you, so it's good. So I hope you are all doing well. And still stay at home. And it's one person has a name XOJI0. I don't know who is that. So if you want, you can change the name. Okay. And I am, let me check my YouTube. Okay. So I am showing you the Blackboard now. Oh, one more thing before we start. I posted the grade on discussion board, the second discussion, and the first part of homework 1, homework 3. So just check your grade, and I post some feedbacks. So most of you got some issue, minor issue, but still some issues in the first part of the homework. So that is why I made the announcement like yesterday or 2 days later. That we're gonna do some adjustment on our lecture today. And we can have a review on the supervisor model, and we'll post our lecture for the clustering part. We're gonna move that later. And I just want to make sure you all get the idea and get a clear idea on the supervisor model and the data types for the variables and when to use what variable and for which model. And also something about the business question. So that is some kind of questions I collected from different people. So I just made another small slides and just trying to do a review. And then if you missed your grade or whatever, I can check that. And some of you have some issue on your submission, and probably you missed something. And if that's the case, just check your grade. If you missed something or if you submit the wrong file, and because I have to give a grade, so I just give you a temporary grade as a 0. And you can check my feedback, and you can resubmit it, or you just discuss with me, and to see what is the issue there. If you don't have a grade and if I missed anything, so you just let me know. And you can type it directly in the chat box, and I can check it later, probably during the break. And if you're on YouTube, and maybe you can just send me email on your grade, okay? And that's something I did this week. And then before we start the lecture, another thing I'd like to mention is that in our discussion board here on Blackboard, add another forum. Well, we have another discussion, but later on the issue of data science. And then I have another discussion board. So I don't require you to post anything, but I would like you to, if you have some information, any thoughts, anything you want to share, and just feel free to post it here in this forum. So about this coronavirus, and it's just for us to share the information. And since you're all learning data science, and you can think something potential solution or potential things data science can provide to us, can help us to deal with such issue, and whether data science can be used for prediction purpose, or like for the control purpose, for surveillance purpose, or all kind of purpose. So you can think about that. If you get an idea or collect any information, just feel free to post it here. And I know you're all in different industries, and probably some industry got affected a lot, and some other industries may be better. I know some, like especially retail industry and manufacturing industry may be affected a lot. But if you are like education, we're kind of okay because we move everything online. So the profits and all those things not affected a lot. It just affect the ways with the labor, the knowledge. So it depends on your industry, and you can also post some thoughts and information you collected. And one thing I want to mention here, so I just make my own post and I will keep updating it. So I haven't got time to finish the whole post. But here I'll give you 3 links. You can take a look. First 2 are the 2 virtualization link. And we'll discuss virtualization using Tableau later. But here are 2 links probably you want to take a look. And 2 virtualization. The first link showing you the map and shows you the risk on infection. I think that's a map based on county. So you can take a look of county or city. So you can take a look on the risks, the residents in a particular city or county, and to get infected by COVID-19. So that's an interesting one. But they don't really say how they did it, and they don't mention what kind of algorithm or the data they use to make such prediction. But it's an interesting visualization. You can take a look. And the second one, it is more comprehensive dashboard to visualize a global case and the global spread on COVID-19. It's made by Johns Hopkins, I think. So Johns Hopkins, they have the center called the Center of System Science and Engineering. And that they collected and updated the data. Now a lot of virtualization and articles and the research, they cite their data set. So basically they have a team who collects the data and every day from all the countries in the world, and to see how many new cases and how many cases and death. And they keep updating the data every day. So a lot of people are using their data source. And then this center, they made a small visualization, and also they update here on total case and deaths and recovered. So it's already 1.1 million. So it's a lot. And you can take a look on this dashboard that they provide some information here. And also some charts and showing you the increase in rates. So those 2 are 2 small virtualization, and now because it's still an ongoing situation, so a lot of people are trying to make what we learned, the term we learned, descriptive analysis on the cases on the COVID-19. So a lot of virtualization online, and those are the information you can check. The third one, the third link I just updated here in the slide. I recommend all of you to take a look. Probably you agree or disagree with the thoughts of the idea here, but I recommend you all to take a look. So there's one article on Financial Times. And this article written by this is actually the author of a book called The Brief History of Humankind. So it's a very famous book. And that is the author who wrote this article, and share some of his thoughts on what's going on and how this COVID-19 may affect the whole world. And it shares a very interesting idea, especially something on surveillance and on the policies the government make. The government made and temporarily approved for this special situation, and then that's what's happening now. So what's going to happen later? So after this emergency situation, and will this policy still be valid, or will they just suspend that, and will they just revolt it back? So there is something people need to think about. So it's a very interesting article, and I recommend, well, highly recommend you all to take a look on this article. And it's a free article, so you can just take a look in the link I posted in this discussion board. Okay. So here is just some information I just shared with you on this COVID-19, and can take a look, and when you got time after work, and you can just think about that. So how such things may affect us, because now I think even more impact than like the World War I or II. So it's more than that, more serious than that. And it's kind of like a serious situation and an issue all the countries in the world are facing. So it might change the whole world later. So just think about that, and feel free to share your idea on the discussion board whenever you want. Okay. And that's it about the discussion board I just posted. So that is that one. And then, okay, let's come back to our lecture. Okay. The next thing is here, machine learning algorithms content. So right over here, our lecture 9 and lecture 10, and other 2 parts of homework. So something I posted last week. And we discussed something on the model evaluation last week. And we also finished the script on classification. So now you shouldn't have problem finishing the second part of homework. And then we're gonna finish our model evaluation today. And then you shouldn't have problem finishing the third part of the homework. So then you're actually done. We only have 3 parts for the homework. So after you submit all the 3 parts, you will get the full grade for your third homework. Okay. And then, so the first part of today's lecture will discuss what we left last week. So it's another thing for the model evaluation selection and the model issue and solution we mentioned last week. And then the second part of the lecture, today's lecture will be a review on the supervisor model. So 2 PDF files, the slides. So we're gonna use the lecture 9 slides first. And we will use the second file from lecture 9 called the model selection and the evaluation IPython notebook. So that's a Jupyter file. If you haven't downloaded that, you can download it and open it. So we're gonna talk more through this script. Okay. And then the slides is right over here. Okay. So here's my slides. And then Okay, so I think the YouTube works. All right. Okay. So let's start from the lecture 9 slides and do a quick review on what we discussed last week. So last week, well, actually the week before, we discussed a classification model and we introduced the idea of classification model. And the last week, I showed you the script we used to run the classification model. So again, we talked about the 3 classification models last week. And the KNN, decision tree, and SVM. And we mentioned another 2 models earlier called the linear regression and the logistic regression. And basically, actually, logistic regression is a kind of classification model. Actually, we discussed the 4 classification models. Let me change the sentence. Say we discussed the 4 models that can be used to deal with classification problems. Okay, so logistic regression, KNN, decision tree, and SVM. And we discussed the 1 model that can be used to solve a problem, which is not a classification problem. If our target variable is a continuous variable, and we can use a model called the linear regression to solve it. So that is the 5 models that we discussed before. And I also showed you the scripts before. Okay. And that is the first thing. So second thing we discussed last week here is on prediction and the evaluation. So basically, we talked about the evaluation and the let me see whether. How about this? I think it's better. I hope. Let me see the YouTube. I think this one is better. Okay. All right. So last week we discussed on the prediction and the evaluation, and we talked several evaluation methods that we can use. And again, because the regression and the classification deals with a different type of output variables. So if the output variable is a continuous variable, which is numbers, that we when we do the prediction and when we're trying to evaluate the performance of the models, and we would like to compare the predicted value or the value evaluated by the model and our actual value. But because that's a number, we cannot match them, exactly match them. So what we use is that we're gonna take a look on the difference, or we call it the errors. And we have the term we call the mean squared error, and to consider the difference between our evaluated method or predicted value from the model and our actual value. And intuitively, if this mean squared error is small, so that means that the value we evaluated or we predicted using the model is really similar, it's close to our actual value. So that means the model is good, the model fits the data pretty well. If the mean square error is so large, it means that the value we get from the model is really different from our actual value. So deviates a lot from each other. And it means that the model doesn't fit our data very well. So that is one measure we use for regression with a continuous output. And then for classification, because it's classification on categorical variable, and for categorical variable, we have labels for each category. And then we can do an exact match. So we can match whether the output we get from the model and our actual model, actual values, or whether they equals to each other or no. So then in this case, when we do the classification, we can simply take a look on this one we call the prediction accuracy. So just count how many correct prediction and divide by the total number of observations we have. So we get the prediction accuracy, and which is a rate. And a rate means there should be a value. That's a value between 0 and 1, or 0% to 100%. And if the value is larger and closer to 100%, it means that we can make more accurate prediction, or the model fits our data set better. And we also mentioned one kind of thing that cannot be explained by the prediction accuracy is a detailed details on the prediction prediction error. And if we have multiple labels in our categorical variables, and even with the same prediction accuracy, and we may have a different errors. And then it depends on how we build our non-hypothesis and what business question we have. Some errors may be more serious than others. Then in this case, we would like to take a look on the errors and where the error happens specifically. And we introduce another concept called confusion matrix, which can break down the wrong prediction by classifiers or by labels. And we can take a look on where the error is. And even two models gives us exactly the same prediction accuracy, we can still consider the models and select the most proper one based on the confusion matrix. So that is a thing we introduced last week on classification. And then again, two model evaluation methods on regression, the MSE, and the method on classification, the prediction accuracy and the confusion matrix. So that is good. And now we said if we have a model, we have a data set, and because it's supervisor model, so for our data set, we have output and inputs. We fit our model and we run the code to check the predicted value from the model and our actual label. So we can compare them and get the conclusion saying whether the model fits our data well or not that well. So that is a conclusion we can get. So basically, it is a measure we can use to make a judgment on the goodness of fit of the model. So that is the one way we can do to select the good model. And then another thing we need to consider is another idea we introduced last week. Is one issue on model fitting. So if we simply consider the goodness of fit using the measures and the method I described before, and there may be a problem on overfitting. So again, just to remind you the concept of overfitting, that so all the data set or all the data observations we collected include two parts. One is the real information part, and which should be used to fit our model. So that is the part we want. And another part is the noise. And that's all the observations, they will have a noise. It's just like a group of people, and each person may have their own characteristics and may have their own life. So they are slightly different from each other. And we consider those characteristics for each individuals as a noise, and which cannot represent the general pattern of the data. But then if you consider about the purpose for the model, that we would like use the model to represent the generalized pattern in the world for a specific business question. We don't want to consider the noise. We just want to consider the real information, or the informative part from our data. And we want a general model because we would like to use a model to make prediction for unknown case. And if we consider both the information and the noise, and our prediction will based on both parts. But the noise is something we cannot predict. So if our prediction is based on noise, then we will not get a good prediction. And that will be a problem here. So when we're trying to fit the model into the data and we're trying to get a generalized pattern for our model, which can make a prediction, which can make a good prediction on unknown data. And the issue we have overfitting, and the definition for overfitting is here. If we, let's say the builder of the model, if we keep pattern our model and keep to make some adjustment to our model to fit the data, we can eventually we can get the model that fits 100% to our given data, and which looks very good and as high as the goodness of fit. However, and that will not give us a generalized pattern, and in that case, the model learns noise, and that's something we don't want. So we call this process, or the tendency of data mining procedure, we call it overfitting. So that's something we don't want. So we want to make sure our model only learns the information, not the noise. Then in that case, if we use the measure we mentioned earlier, it will not work because the measure we mentioned earlier only measures the goodness of fit. And if we want a better fit, and we will definitely end with overfitting. So then we have some solutions for the overfitting. So the intuitive idea here is that we would like to follow what we want on a model, and saying the model fits the unknown data pretty well. So the solution what we use to deal with overfitting is to get some unknown data and fit our model first, and then test our model on this unknown data. So that is a solution we're gonna use. And then we'll have different methods to make those unknown data. And the method we used, we usually use a simple method, and that's something I introduced last week around the end of the last lecture. So it's a training testing site method. So it's a simple method that we simply split our data set into two parts, and we use one part to fit the model, and we use a second part and pretend that is an unknown data. So we use the input variables from the second part, and we put it into the model. We get the predicted value. And then we compare this predicted value with the actual output label from our test site, and just get another either MSE or prediction accuracy. So that measure will be a measure on the goodness of real prediction. So again, we have two measures: goodness of fit. So that is a measure on the difference between predicted value and the real value on our training data set. And another one, the goodness of prediction on unknown data, and which is the difference between predicted value and actual value on the testing data set. So that is the first solution we can use to deal with this overfitting issue. So we introduced this training and testing method, and we said we can simply break it into two parts, and we just use the training to build the model, and we use testing to test it, and then we call the train test loop. Because usually when you build a model in the first time, and you will not get a very good model, probably you will see a problem. And after you apply your testing data on that. So we usually make a loop and keep making the adjustment on our model. And by adjusting either the model itself, and probably you would like to choose another regression model, classification model for the same question, or probably you would like to adjust your parameters in the model. And for example, the decision tree, you may want to adjust the criterion they use. You may want to adjust the size of the tree and to make the model better. So it's different ways to adjust. And you can run in the train test loop until you get the good performance on your test data set. So that is a simple method we usually use, and that's always a method we want to start with because that's simple. Another thing I mentioned here is that for practice purpose and also for your homework, I just require you to, for this train test method, I just require you to split the data set into 2 parts. And then perform the train test loop, that's it. But in reality, we usually split our data set into 3 parts: training data set, validation data set, and testing data set. Because when you keep adjusting your model using that train test loop, and you're using the information from both the training and testing data set, and we don't really have a real unknown data set to perform the final check. So in this case, we like to split our data set into 3 parts, and we use a train and a validation to just adjust our model. So build the model and adjust it. So after our loop, adjustment loop, and we pick the our final winner, and we can apply that on our testing data set, which is a true unknown data. And because we never used any information from the third data set and into our model building or adjustment stage. So in this case, if we still can get a very good result on the final testing data set, and we will deploy this model. If no, then we have to go back and make adjustment again. So that is what we do in the real business, to split them into 3 parts. So that is the first solution we have here. We call it the train test method. Simple solution that can help us to choose our model. And the same thing for regression. So we just use a different the method. So same method we introduced earlier to make a test. And then pros and cons for this method. So train test method, again, like I said, is a easy method. So that is one big pros here. Easy to apply, and you just need to do it once because we just need to split it once, and that's it. So we run model. So that's one operation. We test the model, second operation, then done. So basically 3 steps. So split data, train model, and test the model. So done. It's pretty simple. And evaluation is easy. We just calculated 1 value, so MSE or prediction accuracy on the test data set, and we get 1 value. That's it. So we just check whether the value is good or no. And then that part is easy. So at the end, it makes the whole model selection process it's very easy. So we can easily choose a model. And we just need to apply the same procedure on multiple models or multiple settings, and then choose the best one. That's it. So it's a good thing. And that is why as a beginner in data science, when we learn it, and we always learn this method, it's the first method to train and test it as a basic method to select our model. However, some problems here, drawbacks. The first drawback is a really serious issue, especially in real business. It's a waste of data. So again, let's go back to the model build part. So we said when we build the model learns information from our input data, right? So the information is the observations we collected in our data set. And when we talk about the data collection, like long time ago in the beginning of this semester, so that data collection and data quality is very important because the data represents the possibilities we have in the world. And if we want to get a good model, we should collect enough data, which includes enough information and can show the possibility in the world. And in this case, if we do the train test and we're gonna split our data set, remember the ratio I mentioned. I said usually we use probably 70 to 80% of data as a training. So which means that you can only retain 70 to 80% of information from your data set. So that is a waste of data. So what if the other 20 to 30% of information is really important? What if you have a just a very small data set at each observation? It's very important. And if you drop some of the observation to train your model, and probably your model is not a generalized model because they just didn't include all the information from the data set you collected. And that is one big issue we have here. We call it the waste of data because we have less training data to help us build the model. And another issue we have is that after we build the model and we're trying to test it on the testing data set. However, it depends on how the data is split. Although that's randomly, it's a random sampling method, but random, sometimes when you randomly select something, probably it's just a very bad result, or probably it's a very good result. It's like a lottery. So probably you're gonna be the winner for the big prize, or probably you will never win for the whole life. So who knows? So what if when you split your data and you just put very bad data in the training data set or the testing data set, and then you do the process, all the stages, and you may find a very good or very bad result on the testing data set. So we call it high variance here. So the volatility is pretty high. And if you're trying to perform this, the training testing procedure and using different randomly selected testing data set, you may see a very different result. And then it's gonna be really hard for us to make judgment on one like testing result. So if you see a prediction accuracy very high on testing, it's really hard for me to make a conclusion, say whether the model is really good or no. And what if the test data set is just got randomly selected very good data set? What if the test data set is just a very bad data set? So I don't really know. There are a lot of uncertainty that makes the problem here. So that are two big drawbacks for the training testing method. And usually, again, we usually use it for practice purpose. And if we just want to run a quick test on the model, and we usually use this train testing method. But in reality, before we deploy the model in a real business, and we would like to do more tests. And the people usually choose the second method we have here, which we called, the term I highlighted in this slides, which we call the cross-validation here. So in the slides, I actually include two kind of cross-validation method. Cross-validation, I'm gonna introduce you the idea, and then you will know why it called cross-validation. So validation, you all know the meanings. So this is a method that help us to validate our model and to test whether the model is good. That's why it called validation. So why it called cross? So I'm gonna explain you using the first, the basic cross-validation method that we call the leave one out. So leave one out, cross-validation. What does it mean? So like the plot I'm showing you, we have the data shown as a dot. So we would like to fit a linear regression model. And then if we use all the observations, we're gonna have a green line, looks like this. And if we would like to do a cross-validation, the steps we do is that every time we're gonna take 1 point out. So that is what the term leave one out mean. So like the thing I'm showing you here in the plot, I have a small blue dot and I just take out this point from my data set. And then I use the rest of them to fit the model, which is a line here. And then I get the model and I will run the test on the dot that I just took out. So on this blue one, because it's a regression, so we're gonna use the method mean square error. So I gonna calculate the estimated value from the model for this blue dot for the x value, and then I take the difference, which is the red lines here. That is a difference. So we are able to calculate the mean square error. So we just take a square, and because it's only one, so we don't have a mean value actually. So we just take a square and that's it. So then that's the first, let's call it the round. So first round. And then in the second round, we take out another point. So we take out the second point. Can I do this? Let me see. Let me try whether I can do this. Okay. So I think I can do this here. So, now I got an issue. Oh, okay. So in the second round, we take the second point out, and then we fit another regression, and we again, probably the line looks like this. And then we can calculate the same arrow, and we calculate the same square arrow for the second dot. And then we're gonna make a loop on all the observations we have here, which gonna look like. Okay, go to next slides. And how can I clear all of them? Okay. Okay, here. After we make a loop on all the observations, we will get, I mean, here in this case, I think we have 8 or 9 observations here. Anyway, we're gonna get all the 8 models. It all looks differently. And for each round, we calculate one mean square, one squared arrow. And then we have 8 rounds here. So we had 8 square arrow value. And we'll again calculate the mean square arrow on these 8 arrows. So then in this case, we every time, and when we run the training testing, so same idea on training testing, and it just for our testing data set for each round. And we just have one observation in the test data set. And we return most observations for the training purpose to fit the model. And then every time, because we take out different values, so our model may look differently. It can help us to smooth the variance on the testing data set. So that's drawbacks from the train testing method. And then it helps us to measure the arrow more, let's say, comprehensive. And we can get a more accurate arrow, I mean squared arrow, using this method. So basically, again, to summarize, the idea here is every time we're gonna take out one observation and run the model, and we run the test on this observation we took out. And then depends on how many observations we have, we're gonna run the model several times and make sure we put all the observations in the testing model once, and then we'll get a bunch of errors. So at the end, we just take the mean of all the arrows to get the mean square error. So that is a idea for this leave one out cross validation. So for the name, leave one out, because every time we only take one observation out. And the term cross is because after we run all those models, so for all the models, our training data set, actually they have a cross, they have overlap. And because every time we just take out one observation, so for all the 8 models here for the training data set, majority of the data, and they are cross with each other or overlap with each other. So that is why we call it the cross validation. So that is a good mindset, especially we don't waste any data because we only take one observation. So we think it doesn't really affect a lot because we have so many data. So we don't waste a lot of data. And then we still get the error value, I mean square error. And even from here, you can see some models may have very bad result. And like the first model in the second row, the error is really large on this testing data set. And for like the last model in the first row, the error is pretty small. So we may have very good or very bad result on the testing data set, but it doesn't really matter because we have so many runs. So after we take the average, we're gonna smooth it. So we consider the variance and we're gonna smooth it. So we will not have the same situation as a training testing mindset, and we will not get one very good or one very bad results. And we can't the average on that. So that is a good thing for this cross validation compared with the training testing data set method. So that is a validation method that we usually use. So we call it cross validation. And for this leave one out cross validation, we have one issue. The main issue is that because every time we just take 1 point out, and we're gonna make a lot of loops. And for the example I gave you, only have like 8 observations. And then it's okay. We run the same code 8 times. It sounds okay. But what if you have millions of observations and you cannot run the same code millions of times? It's gonna take forever. So that is a big drawback for this leave one out cross validation. It just takes too long. And because we need to run the same thing several times. And sometimes they may give us very strange pattern. And it depends on what data you take. So when you run it, and for some loops or some runs, it may give you a very strange pattern. So that is 2 drawbacks. The main drawback is the first one. It just takes too long. So then we still want to take advantage from the pros, and we don't want to waste too much data, and we still want to smooth the variance we have or we get from the training testing method. So we love cross validation, and we just want improve the counts here. If it's gonna take shorter, and we prefer to use cross validation than training testing. So the improvement we make here is that instead of leave one out, and we're gonna do a thing we call the k-fold cross validation. So instead of take 1 point, and every time we're gonna take a partition out. So instead of 1 point, a partition. So instead k-fold cross validation, and the k is a number of partitions. So for all the observations we have here in our data set, we can randomly split it into k partitions. In the example I'm showing you here, we use k equals to 3. So basically we have 3 partitions, the red one, green one, and the blue one. And we have 3 partitions. So every time when we run the cross validation, we're gonna take out 1 partition. And for example, the first round, we're gonna take out the blue partition, and we use a green and the red dot to run the model. And we calculate the error. And now because we have 3 dots in our testing data set, 3 blue dots, so we have 3 arrows, then we're able to calculate the mean square error for this one. And that's the first round. So second round, we're gonna take out the green observations, run the model, we calculate the mean square error. The third round, we take out the red partition, and again, we do the same thing. Because we only have 3 partitions, so we only have 3 rounds. We only need to perform the same thing 3 times, and that's it. So the value of or the number of partitions here for the k fault, it depends on your data set, how large it is. But usually we have a number between 5 to 8, well, 5 to 10. Usually we use 5, and we don't want to make too many partitions. And in my example here, because we just have 9 observations, so 5 partitions too much. So I just split into 3. So that is a idea for k-fault cross validation. And each round it looks like this. Estimate the model, we calculate the mean square error, and we repeat the same step for all the partitions we have. So again, this is still a cross validation method because every time or between 2 rounds and your training data set will have cross or have overlap. And then that makes it still a cross validation that we eventually we're gonna make use of all the data we have in this data set and to do the test. So we will not lose any information. And we still, we can get the evaluation, the value at the mean square error prediction accuracy, because every time when we run that, we still take out the partition as our testing data set. So we can still calculate our evaluation measure. And that is a k-fault cross validation, which we usually use. And instead of the training testing method or leave one out method, because that one takes advantage. Say what we mentioned in leave one out cross validation. So it use all the information and it improves the drawbacks, the issue we have for the training testing. So what if we randomly pick a very good, very bad data set? So cross validation, it randomly split the data set. So probably you have 1 partition that is really good or bad, but it doesn't really matter because we run the same process several times. So after we take the average, and we're gonna reduce the effect of this very bad or very good testing data set. So that improves the training and testing method. And because we make the data into partitions instead of leave one out, so it actually runs faster, much faster than leave one out cross validation. So k-fault cross validation, that's the thing we usually use. So again, you can define the k, it's usually a small number between 5 to 10. And every time we just waste a small part of data to run that. And then we run several loops for that. and to make an average and try to smooth the variance of the value on our testing data set, and try to avoid the problem we get from the random selection. So that is a method we usually use in real business called cross-validation. And then two methods we introduced: training testing and cross-validation. So the measure on the testing data set is the same, MSE and the prediction accuracy. So that's the same measure, and we just use a different method to separate our data and to run the training testing in order to calculate the final MSE and the prediction accuracy. And then for each model, and we're gonna have one model and one data set. So you can choose either to use train testing or cross-validation. After that, at the end, you will only get one value. So for regression, you will get one mean square error. For classification problem, you will get one prediction accuracy. And that value will be the value we're gonna use for our model selection. And try to avoid the overfitting issue. So again, that value, it doesn't show the goodness of fit, but it shows the generalization of the model, or whether the model can perform well on unknown data. So basically, we want to get the model that will have good performance on unknown or on testing data set. So that is a criterion we use to select the model. And then the method here is that model selection and how we select the model. Just to give you an example in the slides, if we would like to build the model, here in this example, it's a classification problem, and we want to choose the model between decision tree and the SVM. So basically two different models, and we want to see which one is better performance. And what we do is that we break our data set, and we use the training data set to run it, and we use a testing data set to test for both models. If you choose to use cross-validation, then we do the same thing. We randomly partition our data, and we run a loop. So run the same training testing process several times on each partition and calculate the mean value. For here, it's basically the prediction accuracy. And then we're gonna pick the one with the best performance, in this case, with a higher accuracy rate on the testing data set. So that is the criterion we're gonna use to select our model. So I have this plot and showing you that what we usually do. So for different models, and we may have the different performance on the training data set. So which is, we will have a different goodness on fit, okay? And depends on the complexity of the model, and the performance on the training data set may be very good or maybe bad. So if the model is really complicated, then the model may fit your training data set pretty well. So you're gonna have a really good value on your training data set. So like the first model I'm showing you here in this table. So right over here. And then, oh, I'm sorry, this table showing you the MSE. So the complicated model is the last one. So with the lowest MSE. So that means the lowest error. So it's a really good fit on the data set. And the first model probably is too simple. So it may have very high MSE, so very high error. So probably it's not a very good model. Not very, it doesn't fit the data set very well. So then model, and that is our measure on the training data set. So after we apply our, here the measures on the k-fold cross-validation error, and you can also do it on using the training testing data set. So anyway, after that, you will get one mean square error on your testing data set. So you will get the error here. If the model is too simple, it doesn't really learn the information very well. You will get a very high error on both the training data set and testing data set. And it just means that the model doesn't represent the information very well. So that's not a good model. And then if you keep improving your model, the error on the training data set will decrease and the error on the testing data set will decrease, and until we reach the third model. After that, after you learn all the, after the model learns all the useful information from your data set, it tends to learn the noise. And when it becomes more and more complicated, it's still the error on your training data set is keep decreasing and just decreasing. But the error on your testing data set will increase because your model learns the noise, and it will not have good performance on your testing data set. That's why you're gonna see an increased trend on your testing data set. So you actually see something like a curve, and there will be one model somewhere in the middle that with the lowest error on your testing data set. And that will be the model we pick. And that is a criterion we use to perform our model selection. So basically we will pick the model with the lowest error or best performance on your testing data set or on the unknown data set. So this model selection criterion matches with our intuition and our purpose to run a model, which is that we would like to use a model to represent the general pattern in the world for our business question for our data set. And we're gonna use the same criterion to choose a model. So with a high, with a best performance or the lowest error. So in this case, we're gonna pick the third model. And to make it more general, for each data set and model, if you keep adjusting your model, and you will see a plot looks like this. So this one is example on classification. So instead of error for classification problem, we're gonna use accuracy to measure the performance. And again, accuracy between 0 and 1. And the performance on training data, if you make your model more and more complicated, and the performance on training data will be better and better. So that is the first line on the top. You can see it has an increasing trend. Starting from the beginning, thinking beginning around here, so 60-something%. And then if you keep making the model more complicated, so here the complexity is measured by the tree size. So how many nodes we have on decision tree. So if you add more and more, and it's gonna be better and better and approaching 1, so almost 100%. So it means that the model fits perfectly on your training data set. But the performance on the holdout or on the testing data sets is different. Very beginning, and it's gonna increase in a little bit, and from around 60% to 70%. And then after a point, it's gonna keep decreasing. And when the model become more and more complex, it's gonna decrease more. So that is has the same trend as a table I showed in previous slides. And when we pick the model, again, we're gonna use the same criterion. We're gonna pick the model on here. We call this sweet spot. So basically that is a spot has best performance on the holdout or on the testing data set. So that is here in the middle. So then in this case, when we select a model, we will select the model with the best performance on testing data set. So that is example for classification. So best performance means highest accuracy. Okay. So then when we trying to do the model selection, in reality, we don't just test on 2 models, and we'll do something like this plot, or like the previous table. We can then test multiple models, or multiple different settings for the same model. We're gonna start from a very simple setting, and include just a minimum size of features, and we make a simplest one, and then we can keep improve the complexity of the model, and trying to make better and better performance on the testing data set until we see the sweet point and we see the change on the testing performance on the testing data set. If it's not increasing, if it's starting to decrease, and we know we reached the sweet point, and we're gonna review all the models we tested and pick the best model has best performance on the testing data set or the sweet spot. So that is again criteria we use to select a model, usually you can either make a table to just record all the performance on the testing data set, cross validation, or you can draw a plot like this and to help you pick the sweet spot. Okay, so that is again the method we can use to test our model on the data set and the criterion we use to select the best model. Okay, so that is a method here. And the next thing I can show you is our script, which is actually not that complicated because we already discussed most of that last week. Okay, so here is our model selection and evaluation script, Python script. We already discussed the model evaluation measures and how to calculate mean, square, error, and accuracy score last week. So here I just add some other things and showing you how to perform the train testing and how to perform cross validation on your model. So the package we use, the machine learning package, sklearn, Python package that we used, is 2 lectures. It provides the training testing split and it provides you the cross validation function. So you can use that directly. You don't need to like manually write the loop for your model. No, you don't need to do that. So it's not that hard. And then for the script, I will help you go through the script. It's not a very long script, and we still use our insurance data set. And then the first method is actually something I showed you before. So training testing method. In the sklearn package, the model selections, the package, we have a function called the train test split. Okay, so that function can be used to help us split the data set into 2 parts. So train test split, it takes 2 inputs. One is our input variables, which is a data frame, and you can include as many columns as you want. Another one is our output, and which includes 1 column from your data frame. and our test size and what is the percentage for your test size. So here I use 25%. By default, if you don't put it, I think the default ratio is 75% and 25%. So you can also make adjustment to make the test set larger or smaller. And then that is this function. The function gonna return you 4 things. So it's gonna split on your input and the output. So basically you will get 2 inputs or 2 X. One is a training X, another one is a test X. And for your output, it will also split into 2. So you will get a training output and the testing output. Because it returns you full value or full set of outputs from this model. So I defined 4 Python variables to store those 4 pieces of data. So I have my train and test X, train and test Y to store all the information. So then I load the package, I split it, and you can check. So here I just check the shape of the training of my training data set to see how many observations we have. So in our insurance data set, we have 1,338 observations, I think. So after we split the data, and for our training data set, we only have around 1,000 observations. So for other of them, other like 1/4 of them, it's split into the testing data set. So then that's our training data set, and we can fit our model. We just do the same thing as what we did last week. So here I'm using the decision tree model. Decision tree, I remember that we initial model, we fit the model, and then we test the performance, okay? So what I did is that I fit the model using the 2 training, training X and the training Y. And then I would like to check the performance on the training set and the testing set. So again, I would like to calculate the accuracy score using my training X and Y, and also my testing X and Y. So after that, my code.
Sorry, quick question. Yes. On the decision tree depth, you only have to go 1 there. You don't have to go any more than that.
I have these 2 blocks of code.
Oh, okay.
Well, actually 3 blocks of code. You can make adjustment.
I see. Thank you.
Yeah. So this one is like the simplest decision tree. I only have 1 level, and that's it. So I make them more and more complicated. So by adjusting this maximum dips. And again, decision tree, you can adjust other things, like the criteria they use to split the node. But here I just use maximum dips. The first one, the simplest model. So we see it's pretty good. 92% on the training data set and 93% of accuracy rate on the testing data set. If we look at directly, it looks pretty good. But we would like to do further tests and by making the decision tree more and more complicated, okay? So we do the same thing, exactly same code, and just 1 difference on the maximum dips. I make it using a larger value. So now I make a maximum dips equals to 3. And you will see that performance on training data set now becomes 96, almost 97%. On testing data set is 96%. Both becomes better than the previous model. So I think it's okay. It's better. If I compare this to, I'm gonna pick the second model. But I don't know where my sweet point is, so I'm gonna keep doing that. I do another one with a maximum dips equals to 7. This is even more complicated tree. Again, the same as the plot I showed you. when your model become more and more complicated, the performance on training data set will become better and better. Now is 98, almost 99%. So it's the best one among all the three. But the performance on your testing data set, now it drops to around 95%. So if we use our criterion to pick the model, and based on the performance on testing data set, then the third model is actually worse than the second one. And first model is worse than second one. So seems like the second model here is gonna be the best one. So now my sweet point is the second model, and we go back, check the setting for the second model. Second model is a decision tree with maximum dips equals to 3. So that is the final model we're gonna pick, which has the best performance on your testing data set. Okay. So that is one with a classification model. And you can replace this decision tree because the same thing. You can replace it, this decision tree function with SVM and KNN. So you can test it. So KNN with different case, SVM with different kernel functions. That's something you can do. And then that's the one example on classification problem. Next one on a regression problem, mean square error. So we do the same thing. We split it, and I initial the linear regression model. I fit it. So I initial model, I fit the model. I get a predicted value using my testing data set. And then I compare my real testing data set output variable, the test y, and the value we predicted from linear regression. So I get a mean square error, which is this one. So it's pretty large because our output now is charges. So charges value it has a very large the variation. So it means it makes this mean square error very large, but it's okay because it's a relative measure. So we just want to compare to two different models. So now I'm gonna do the same thing, and I still use the linear regression, but I'm gonna add one more feature. First model I only include BMI, and second model I only I add the age variable here. So I include two independent variables. BMI and age. I do the same thing. I calculate the mean square error on testing data set. Now you see the mean square error is decreased. So if we just want to compare two models, I'm thinking the second model is better than the first one. Apparently there's some information in the age variable. Seems like age provides something to the charges. This somehow related to charges that we can use the age as the input variable into the model, which will give us the good or better performance on the testing data set. So that is the conclusion I can make here using this training testing method on regression model. Okay. Again, just keep in mind, regression model, we use error to measure it. So we want a smaller error. And for classification model, we use accuracy to measure that. So we want a larger accuracy rate.
One more question, Professor. Thank you.
Yeah.
I see that on your test, you did the age, BMI, and children. But then when you ran the two models, you did just the BMI and age. Would it be required to then use the children also to then see what the result of that model is?
Oh, it's there's no like requirement on anything. So when we pick the features, and I think probably these three features all relate to charges. And then you can do a test. So I just give you an example using this tool. If you think children may also relate to charges, you can add just a copy paste and another one and add the children to that and to make a test. or if you think, if you change your mind, you think children doesn't really matter, then you don't need to. So what we usually do when we do the training testing split, you can include all the variables you have that you think can be potential input variables. So just to make sure that, I mean, you don't need to make adjustment again. So you just include everything, and when you build the model, you can choose the features that you want to use to build the model. But you only need to split the training testing once.
Thank you.
Okay. Okay, so that's this one, training testing, and the second part, cross-validation. So here I just have some like explanation here. It's what we discussed in the slides. And then cross-validation, just one more function. Cross-validation is a function in this sklearn package in the model selection subpackage, the same subpackage, and the function called cross_val_score. So basically, it will help you to do the cross-validation to run all the models and to calculate the final score for you. So it's pretty easy. Just the one function, it's gonna return you one value. If it's a classification, it's gonna return you the accuracy rate for each loop. And if it's regression, it's gonna return you the mean square error for each loop, and that's it. So it's a pretty simple one. And then what we do, I mean, how we use a cross-validation function is just one line of code to get the cross-validation scores. Because it's not training testing, so we don't need to split it. We just need to pick our data and pick our model. Because we need to pick our model, so before that, we need to initial our model. And we're gonna run the model initialization here. So I initial a empty model with specific settings. So I use maximum dips equals to 3 decision tree. And then I'm gonna use this cross-validation score function. It takes 4 inputs. First input is the model we initialed, this empty model. And second input is our input variables. I use 2 input variables, charges and BMI, from a data frame. And the third input variable here is our target, so which is smoker from the same data frame. And then the last setting to do is cross-validation, basically the K. So how many faults do you want, or how many partitions you want. So here I use 5, okay? So it means that the function gonna help us break your data into 5 partitions, and it gonna run the model 5 times. Every time it gonna return you 1 mean square error for the particular partition. So then at the end, you're gonna get 5 mean square error values. So in the function, you run that, it gives you the output. So it gives you the output, which is a list of cross-validation scores. So basically, it just gave you the score directly, and you don't need to use any other function to make a calculation. And then you can see, because we apply the model on different partitions, and some partition may have bad results, like the second one. Some may have a very good result, like the third one. So it varies. And then at the end, we just take the average on the majors. So here, accuracy score. And the next one, okay, you can replace it with linear regression. I don't have a linear regression example here. So after that, and you calculate the mean value for all these scores, and you will get the average accuracy score. And you apply it on different model, on a different decision tree model with a smaller value on maximum dips. So basically a simpler model. And we do the same thing, calculate the pre-out score and calculate the mean value or average value for all the accuracy score. And you can compare these two models. Again, we get the same conclusion as the training testing method. And the model, the simpler model, will have worse performance than the first model we have with maximum dips equals to 3. So this one we have 96%, and the simpler model we have only 92% or 93%, which has a worse performance. So if we just compare these two models, we're gonna pick the first one, decision tree with maximum dips equals to 3. So that's based on cross-validation scores and the mean value or the average for all the scores we have on all the partitions. And you can also adjust a CV, the cross-validation partition number. And especially if you have a larger data set, probably you want to make this value larger to just make more partitions. And if you have a smaller data set, and you can reduce this number. And at the end, we just need to check the average for the score. That's it. Okay. So that is a idea here. And at the end, I just have some other information at the end of this this script, and show you how to do. So it's just a summary of the functions that we used, training, testing, cross-validation function, and the classification matrix. So here I also showed you how to guess a confusion matrix. So sklearn provides you the confusion matrix that you can do it directly. So you can break the accuracy score to a confusion matrix with true positive and true negative and false positive, false negative. So that works on a binary classifier variable. So here just a summary for what we discussed on model evaluation measures. So that is what I have for this script. And our homework. So the third part of our homework here is that I would like you to use a Titanic data set and just use classification model on survived on this survived variable as output, and they use those as input variables. And then it has the 4 different models and checks the performance of these 4 models. So I would like you to pick the best model use if we would like to predict whether a passenger gonna survive or no. So which model should we use? Again, we learned 4 models: logistic regression, KNN, decision tree, and SVM. So you can do this test on all the 4 models and pick the best one. So that is the third part of homework that I would like you to do. And I also like you to use both methods, the training testing method and the cross-validation method. So you can use a script I just showed you to finish the third part of homework. Okay. Okay, so that is a script, and that is all the content about model selection and the evaluation. So do you have any questions so far? Okay, so anyway, if you have a question, you can just type it on the chat box. Let's do a break. After the break, I can help you do a quick review on the supervisor learning models. So basically what we discussed in the past 3 weeks. And if you don't have any question or any problem on the supervisor learning model, and you just feel free to leave the meeting room. You don't need to stay here for another hour. And if you still got confused on something on the variable tabs on the models, when to use which model, and the applications, whatever, you can just type your question in the chat box during the break, and we can discuss your question. And I will also show you something I prepared in the slides to help you just clarify something on the supervised learning model, okay? And then let's do a break. So let me give you 15 minutes break, okay? So let's do a break, and I will check your question in the chat box.
Professor?
Yes.
Question regarding the part 2, homework 3, part 2. I don't know if now would be a good time to ask it, or if you want me to save it for after.
But well, you have the issue on the file, right?
No, that I finally got to you. I got, that was the part, I think that was the part 1. I did that today during our lecture. I did exactly what you said. I saved the PDF and then uploaded the PDF file.
Okay, okay.
But my question was specifically here. Let me, you mind if I share the screen with you real quick?
You can, wait a second.
I should be able, oh, no, host disabled. I see, you disabled the sharing screen. It was when I was running the matplot, what is it called? Let's see, how do you inline PLT scatter plot? There was a couple of us working together, and our scatter plot didn't come out anything like yours.
Wait a second. Let me see, how can I see your screen?
Maybe let me see if I could send this file to you. Let me see if, no.
Do you have a share screen button?
I do, but when I clear share screen, it says host disabled, participant sharing screen. So you may have set a setting, so none of us, which is all right. I mean, it's not that serious. Maybe
Okay. Wait a second. You can try to share your screen now.
This will stop other screen sharing. Do you want to continue? Yes, let's see. And then 3. Okay, thank you. And then okay.
Let me see. Okay.
All
Okay,
right.
let me see.
This is like nothing at all like yours came out.
So you're doing male, female. So that is your axis,
Right.
and your Y is I don't know.
Let's see.
Probably it's
Survived is the Y.
okay.
My X, the features, I guess these are the features, right?
Yeah, those are the features. But when you did the plot, you only use the first one. So basically it's sex. That's why you can see male, female in your plot.
Sorry. So in here, which number are you referring to here? Which one?
No, you scroll down to your plot. Yes. So when you do that, you're calling the first column. So basically, so that's the sex column.
In here?
Yeah. So it's position 0. So that means the first column. So that is why if you scroll down a little bit to see your plot, So the white, yeah, it shows male, female. So that use a sex information.
Because on yours, I thought I used the same code, but on yours it splits, you know, like with your, let's call it yellow hair and your purple down here, so it shows a nice kind of distinctive split.
That's an insurance data set. So you're using a Titanic data set, yeah. And we because we haven't discussed on the plot thing, so yeah, I don't require you to plot anything. So you can, I think, yeah. So you can ignore this part first, and you can just do the accuracy, prediction accuracy.
Yeah.
Yeah, and do the evaluation.
And that would be for the next part, you mean, or for within here, do the prediction? You mean, so instead of running this plot, just run the prediction accuracy?
Yeah, prediction accuracy for the second part, I would like you to check the goodness of fit. So that means the prediction accuracy on your training data set.
Okay.
Right, yeah, so the same data set you use.
Okay.
Yeah.
All right, let me stop sharing now. Thank you. I appreciate the help. Thank you, Professor.
Okay, no problem.
Professor, I have a question if you're available.
Yes.
I have a, I tried to do homework part 3, part 2. And then it comes to a result of like model and then scores. Is that what you're looking for with the accuracy, like what you're asking on the homework where you said accuracy on all 4 models? Is that the scores that you're looking for?
Which part? The second part? Or the
So
third part?
when I run the 4 models for the homework 3 part 2, and then I check the prediction, is that when we check the prediction accuracy, is the scores that it comes to the result? Is that?
Oh yeah. So all the full models are classification model. So you use accuracy score, and use a predict function, and then you get a score, and that should be 0 point something. Yeah. So that you just need to show the score for all the full models. So that's it for the second part.
Okay. And we need to send it in a PDF or in we send all the notebooks?
Yeah, you can send a notebook. No problem. Yeah.
Thank you.
Okay. So let's come back. Okay. I found that I forgot to grade the second homework. I don't know. I think I just missed that. So anyway, I'm gonna work on that, and you should receive your feedback on the second homework soon. Okay. And then gonna use the rest of time and discuss, just do a quick review on the supervised model. Let me make this larger. Okay. So I decided to do the review because I checked the first part of your homework 3, and I find most of you, actually most of you still have some issue on either the variable tab or the difference between classification and linear regression. And probably you also have some question on the business, so how to define a good business question. So I just summarize on what we discussed before, and help these slides help you to review all the contents related to supervisor learning model, especially related to predictive analysis. So you can use what that listed here as a small guidance or help when you're doing your final project, and you can get some information from these slides. So that's the slides I posted on Blackboard and the lecture 10, I think. So you can take a look on that. There is one thing I forgot to start my recording when I discussed about model selection. So we'll not have a recording this week, and I will do a recording on the review part. So I hope it will not affect you a lot. So just let me know if you have a question after the class. If you review the slides and you still have a question, we can discuss about that. Okay. So a quick review, the idea of supervisor learning, and I find some other supportive materials online that we can use to do this review. And here is a like a plot with some procedures in all the stages in the data science process. It may help you get a better idea and help you to combine all the contents we discussed before in all the 10 weeks together. So again, a data science process, or you can consider it as a structure for a data science project. It always starts with a question. And what I always say, the business question. So it's gonna be a question that we can answer using a data science project. And then after we get the question, we'll need to get the data, and we take a look on the data. We call data exploration. We explore the data, and then we see. Basically, we try to use exploration to get an intuition on the data. And to see whether there's a relationship between our data variables and what kind of pattern my data may have. It can help you to choose a proper model as well. And then we model our data, and we show our model. We can also virtualize our data, and to show both the result and some patterns from our data set. So that is a whole process that we usually do. And probably it's gonna be a loop. It's always a loop between each two process or stages here. And if we find a bad result at the end, so probably we need to go back to the very beginning and to double check our question and our data set to see whether there is any issue. So probably we need to collect more data, and probably we need to and just restructure our question, and probably we need to change the question. So it's something we need to consider after we get our results. So then that is a summary for the process. And in the slides, I focus on two parts, so a business question part and the data variable part. So here, start from the business question. I actually put a reference here if you like. It's a reference from Microsoft. And most of them is related to some platform on Microsoft, how they do machine learning, and you don't need to read all of them. But the link I provided here as a reference, it gonna direct you to an article called How to Do Data Science. And that article may help you to get some idea on how to frame a business question and how to pick the data and what is the relationship between our data set and our business question. So if you're interested in that, you can click the link on the slides and to take a look. So let's come back. I copy some, well, I don't want to use the word. I borrowed some sentences from the article, and I put it here in my slides. So again, and which can help you to choose a proper output variable, and it can help you to come up with a proper business question. If you still have issue on your final project, I hope it may help you. So let's come back to the data science, and we define data sets in the very beginning of this semester, and we said that we would like to use some scientific method to explore the information we have in the data science in our data set, and a more specific definition here may help you link the model and our data is that data science is a process of using names and numbers to answer a question. So basically, we have two kinds of data to answer a question. So the two data is names and the numbers. Names refer to categorical variables or a label of category. So basically, it's just a categorical variable. And the numbers refers to an actual number, so we call the numerical variables. So we have. So basically, we would like to use name and a number to answer a question. We have a question, we get an answer. It can be either a categorical variable or a numerical variable. And the answer for the question will be the output from our model. We're gonna use our model and build a model on a data set to get either a name or a number that can help us to answer a specific question. So that is why here in the parentheses, I add the information. So the output is either categorical variable or is numerical variable. So that is the output from our model. And then that is why we introduced two supervisor learning method, and one for categorical output, another one for numerical output. And then before we take a look on the model, we can firstly think about the question. And those are some phrases in the article. So give you an idea on what kind of question or business question we can have for a data science project. Two examples, example for pool question and the example for good question. So example for pool question are like, what can we do? Or how should I do such and such? And those are the questions that cannot be answered by a name or a number. So how can you answer the question? How can I increase my profit? So how can you answer this question using a number or using a name? I just cannot do that. And if you gave a number 10 or a name, called what? Finance. It's not an answer at all. So then those questions, if it cannot be answered by a name or number, we don't consider it as a good question for a data science project. So it is still a question, but it cannot be answered by a model, and we cannot use it for our project. And another example, clear question. And if we ask a question, how many blah, 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 or which one, or whether it is blah, blah, blah. Those questions can be answered by a name or number. So if you start with how many, I'm gonna tell you how many. So it's 10 or 11 or hundreds. If you ask me which one, so which car, ask which model, which brand, I'm gonna tell you the brand, either BMW or Nissan or something else. And then that is a name. So I can use a name and the number to answer the question. So those will be the good questions that we can use for a data science project, because we can link the question with a model. So let's come back to your final project. And if you're trying to build your final project, you need to consider a question that belongs to the clear question. And then that is just for practice purpose, your final project. And if we further consider in real business, so what's happening in real business is that the question may be very broad, especially for, I know most of you working full-time or had some working or either full-time or internship experience before. So if you work for a company, and you will know the real business question is pretty broad. And like the manager in the company trying to solve some problem, like the example I gave you here, we're trying to make the budget for next year, and we need to make the decision how much, or what is the budget I would like to put for our personnel, for each department, for our technology department, for our production department, for all kind of departments. So what kind of budget should we put? And then the broad business question is just we're trying to get the budget done for next year. And that will be a real broad business question, but that is a question cannot be answered by a simple or one single data science project. So when we're trying to provide some information to this real broad business question, and we like to use our domain knowledge and to split it into smaller pieces. So basically, we would like to split the whole big question into smaller answerable data science projects. And for each project, it will have a single very small question that can be answered by, again, by a name or a number. So I give you a small example here saying I would like to consider budget. So just on a personnel. So for personnel, I have a budget on two parts on current employee, have a typo. So current employees or new hiring. So probably two parts. And then for the two parts, I have a smaller question. And I want to consider how much I want to put on new hiring. So how many employees do I need? And do I need to hire new people or no? And if yes, so how much should I put? And what about the current salary for my current employee? Do I need to increase it? How much? And then what about the budget? And then what about the pension or insurance I need to pay? So all those questions can be answered by number, and which can be a real question for a data science project. And then I can consider one more step on the models we can use. So like how much, the last question, how much should I pay for the pension and insurance for my employee? And what you can do is you can definitely collect the past information and saying how much we paid the last year for each employee. And then you can further consider, for example, the information on your employee, what is the age, and are they married? Do they have children? And then what kind of insurance plan they usually pick. And you can make a sort of prediction and to predict whether you need to plan more or less budget on this particular item. So that is the thing we need to do in one particular data science project and for this small question. And then you definitely hear at least 3 questions, and probably you're gonna need 3 projects and work on each of them. And then when you trying to saying report or support the whole business decision, you can combine all the answers from all the smaller questions together, and we just add them together. So basically that's our estimation on the expense. And which can help us to make the decision on the budget. So that is what you can do in the real business. And that is a difference between just a small practice and the real application in business. But again, that is a thing a data scientist needs to do. A data scientist needs to assign job on data analyst, and the data scientists need to have a domain knowledge on, in this example, on budget. So what is mean by budget, and where should we put budget, and what is our cost? And you need to understand the whole structure on that in order to come up with those smaller questions, and which can be assigned to each data analyst. Okay. So that is about the business question. And that's something can think about. And then after you have your business question, and you know that can be answered by a name or number, okay? And then you will have an idea, so what kind of categories or categorical label, or what kind of numbers that you can use to answer your question. So then for our supervisor learning model, and we need to check our data set. So whether our data sets have the examples of the answer. So I'll give you 2 examples here. So I ask what will be the stock sell price or stock price next week. So then the answer is stock price. I would like to check my data set to see whether I have the price for my stock. So because it's gonna be the target and for output variable for my model, and I need to make sure I collect such data and in order to build the model. If I don't have the sell price for my stock, then how can I build the model? That will be an issue. So you're going to check your data set. And second question, how many hours, blah, blah, blah. And before it fails. So you need, again, you need to have the number of hours or failure times for this particular model. And that is the information you need to have in your data set. So again, after you come up with your business question for your project, you need to check the data set and make sure you do have an example of answers to your question. And those examples of answers can be considered as, we call it target variable or output variable in your model. So which is our Y variable in our Python script. Okay. So that is our business question and how it links with our data set. And then after that, we make sure our data includes our target variable, which is good. And we may have other variables that we would like to use as features. So before we run the model, we would like to select the features. So we had in later we had a lecture talk about the feature selection, and in your final project, I would like you to select your feature at least based on your intuition to select the proper features. And the features or the input variables are usually either categorical variable or numerical variable. And there's some mistake I thought you made in the first part of your third homework. Numeric variable and the categorical variable. So examples and more details here. So numerical variables and numbers, and it can be either discrete or continuous. Discrete value is counted. So like in the Titanic data set, we have the number of siblings, number of parents and children. So those are counted, then we consider it as a discrete variable. And the continuous variable is measured, and it means that it's continuous. It is not an integer or something. It's not disconnected. So in the Titanic data set, we consider two variables as continuous variable. One is a fare, which shows the fare of a ticket. So basically a price, dollar amount. So a fare can be $10, $20. It can be 10.1, and it can be 10.5, 2, or 9, or you can add more. It just usually when we use it in reality, we just round it to 2 decimal places. That's it. But it can be continuous and no break or no disconnection. And you can keep adding decimals for the numbers. So that makes this fare variable as a continuous variable. And age is another one. It can be considered as continuous. And just usually we use integer. If you ask how old are you, and usually we said an integer number. So 10, 20, 30, 40, or 41. We use integer to answer the question. But the age itself can be something like 10.5. It depends on how many days past your birthday. So we can do that. So that is why we also consider it as a continuous variable. And those are 2 continuous variables. We have other numerical variable in the Titanic data set. Again, the number of siblings and the parent children. Both are numeric, but those are discrete. And because we cannot say that you have 2.5 children, we don't say that. So we count how many children. 1 is 1, 2 is 2, and we don't have anything between 1 and 2. So that makes it a discrete. There is a disconnection between 1 and 2. You don't have anything else, so there is a gap. That is why we called it a discrete. But all the 4 variables are listed here. Those are considered as numeric variable. And that is the difference between discrete variable and the continuous variable. And even both belongs to a numeric variable. And the categorical variables, and that is a variable showing the information on categories. And there is no intrinsic ordering, and you cannot make a calculation on that. So in Titanic data set, we have several categorical variables. P class is a categorical variable, and sex survived, embark. Those are all categorical variables. We don't distinguish categorical and numerical variable. We don't distinguish them based on the value displayed in the data set. So which means that for the P class, that is a variable. A lot of you made a mistake on this one. So P class, that is considered as categorical variable, although in the data set, A has a value 1, 2, 3. But if you check the definition, as most of you did it in your second homework, I just checked. Most of you check the Kaggle's website. If you check, you will see the P class is a proxy of this social class or economic status. So it's upper class, middle class, and the lower class. So you can consider it as not very accurate, but you can consider as rich people and the poor people, something like that. So we will consider it as numeric. So I don't really think so. And although it's shown as number, but it's actually a categorical variable because the category is upper, middle, and lower. Okay. So that is why we treat it as categorical variable. And sex survival, that's the same. For the survived, it's shown as 0 and 1, but we consider it as categorical variable because 0 and 1 means no and yes. So it doesn't mean anything else. So that is the categorical variable, and it has a meaning for each number. And we cannot make a calculation on that. So it's just a trick if you just got very confused on a variable and whether it's numerical or it's a categorical variable. It's just a small trick, and you can see whether you can add the values. So like say the fare, it's definitely we can add it. So 1 ticket costs $10 and 2 tickets cost $20. So we can add them together. Number of children, we can add them together. Say you have 1 kid, well, I have 1 kid, and then we have a whole community. So we will have, in total, we're gonna have 25 kids here. So we add them together, no problem. And for P class, we call it categorical because I would say I'm in class 3 and you're in class 2. So we are in class 5, we don't say that. So we cannot add them directly. And although it's number, but it doesn't make sense. So that is a thing can help you to distinguish between categorical and numerical variable. So simply see whether you can add them together. Okay, so that is a on a data tab, 2 tabs of data that we consider. In the Titanic data set, we have 3 more variables: a name, ID, or passenger ID, and the cabin, I think. So we have those variables in Titanic data set. And those are the things we consider as qualitative data, or like individual characteristics for each observation. And those are kind of unique for each observation. And it doesn't show any pattern. And it doesn't, we don't consider them as either categorical or numeric variable. And usually we don't include them in the analysis. So example, your name. And it just belongs to you, the specific observation, and it doesn't show any pattern. So we don't consider it as categorical or numeric variable. Your ID, your phone number, your address, or detailed address, and usually we don't consider that. But for the address part, we can consider, if we want to consider where you live, we can consider the county or the city you live. If I want to study like a community, or I want to study something on social science, and I can do that. If I collect the city or the county you live in, and I can consider it as a categorical variable. But if you give me your detailed address, including the apartment number, we don't consider it as either categorical or numeric variable, and we don't include it. We don't include it in our analysis. And actually, when we do our data description and our model, we don't include it at all in our project. So probably you just collect the data, but you leave it in your Excel file. We don't really use it. So that is another mistake some of you made in your homework. Some of you include the things ID and like the cabin into your model. So that's something we don't do. So those are the features we have. Again, we select the feature. Firstly, we filter out these individual characteristics. So we exclude them and we only keep categorical variable and the numeric variable. And then you can use your intuition to select because you already know your target. So you just pick the set of input variables that you think may be related to your target, and that's it. So again, different people are gonna have different view on your data, and you may have different thoughts. As long as you can provide a good logic and explanation on that, then you can definitely include the feature variables in your model. And in our lecture, we discussed some other techniques to perform the feature selection. But I don't require you to do that in your final project. So at least in your final project, make sure you pick the feature intuitively. So based on your understanding on the data set. Don't just throw everything. So if I say you throw everything, but I think it doesn't make sense, I may question you. So why you include such variable? Okay. So that's a feature. And the data preparation, two things you need to check: missing data, categorical variable. Missing data, if you do have any, the Python code is gonna return you error. When you run the model, if you see any error, and the arrow, you can scroll it down to the bottom, and usually in the arrow box, it can they're gonna tell you like missing value error, something like that. So you will get the message from that. And you should be able to know that there is because you have missing value in your data set, and you need to go back and check. So that is the one issue and can be controlled by the program. Second issue you need to consider is that whether there is a categorical variable or no. And if yes, you need to convert it into dummy variables. And especially for models, if for models with mathematical formula like regression model, FINC model, and KNN, and no matter whether the variable is shown as number or label. Why is that? I have the slides here. So this one is for missing data. And just to make sure you deal with missing data. And usually, if you don't have too many missing data, you can just remove it. Or you can use a FINC to do the imputation. And the categorical variable, again, we have three categorical variables: survive the P class, embark, and I think we have something else. Sex, I think. So those are categorical variables, and we need to convert it into dummy variables. And there's special case. Survived is a special case. Survived itself is already a binary categorical variable, and because it only includes two classifiers, 0 and 1, so we actually don't need to change it. We can just use it directly. And for others like P class or embark, it shows more than two categories. And that is two variables you need to convert into dummy variables. And then again, P class, although it's shown as numbers, but it's a categorical variable and has more than two categories. So we need to change it into dummy variables, and we cannot use it directly in the regression model. So that is another mistake I thought some of you made in the homework. And the embark, and you, most of you did it pretty well in embark. I think it's mainly because embark shows as a label, so you cannot use that directly. Then you have to make some adjustment. So then in Bark, you can change it to dummy variables directly. So using the same code. So because I thought some of you use a p-class value directly, so I put the question here, and why can't we use a p-class directly since it's already a value 1, 2, 3? And the reason here that if we choose to use a value as input in the regression model, we need to make sure 2 things. So first thing, it has intrinsic order. It means that we can compare the value and to see which one is larger. And because the regression model builds a relationship between the input and output, I have this explanation here. So if we would like to build a regression model on ticket fare, and we will have some equation, like a math equation, to help us to make calculation. I include 2 independent variables, number of kids and your p-class. If you use a p-class directly, and then it's gonna be a problem. If we consider the part, so number of parents and kids, and we can see that we can make a conclusion based on the model that if we have 1 more kid, and then the ticket fare gonna increase by 0.2. So that is a conclusion we can make here. And if we have more kids, it's gonna include more, and then it makes sense. But then for the p-class, the ticket fare increase if p-class decrease, well, because it's a coding issue. So p-class equals to 3 means a low class, and 1 means upper class. So it means if our p-class comes from 3 to 2 to 1, and the ticket fare increases, it seems like it makes sense because the upper class pays more. Probably it makes sense for this one. Not sure. And then we're gonna need to use here the second criterion to check. So we can take a difference on the 2 values to see whether it makes sense or no. So if we consider that, again, for the number of kids and the parents, it makes sense. Increase 0.2 for each additional child, it makes sense. But for p-class, so we said the p-class gonna decrease 0.3 if you move from a middle class to lower class, or if you go down by 1 class. But I don't think that statement makes sense. And I can now say that the difference between middle and upper class and difference between middle and the lower class is the same. And I don't think it makes sense. They just, they're not comparable. And we cannot make such conclusion. So then in this case, use p-class directly in this regression model doesn't make sense. And we need to take a look on each category individually. So that is why for this p-class, so it's another reason why we need to convert this p-class into dummy variables for each categories we have in this p-class. So that can help you to, again, make the decision whether the input variable is categorical variable and whether you would like to convert it into dummy variables. So that is something to do before you run the model and data preparation. So that basically is another thing, and some other things on data preparation, cleaning, so things we discussed, and the like outlier, like whether the data fits the assumption of the model. Again, in your final project, I don't require you to do all those. I will require you to do at least 2 things. So make sure you don't have missing value, and make sure you convert all the categorical variables into dummy variables. So it's 2 things, the 2 like must do steps for your final project. Okay. And then that that will be it for the data, and you just need to select the proper model, and that's the thing I asked for the first part in homework 3. We just discussed the 2 models, regression, classification, and we said that for target output variable, if it is a categorical variable, we're gonna use classification for models, and if the target variable is continuous variable, we're gonna use regression. So 1 model, linear regression. And in our Titanic data set for our continuous variable, you can go back to previous slides to check. We only have 2 continuous variables, fair and age. So those 2 can be 2 candidates for linear regression. And you cannot use other variables as a dependent variable for regression. So that is a model selection part. And then another small trick helps you to decide which dependent variable to use or which model to use. Just to keep in mind, linear regression model is a math equation, and that can help you do calculation. So you can think after you build the model looks like an equation that you can calculate based on your independent variable, so which is the left-hand side on your equation. And you do some math calculation, and you calculate the value for your dependent variable. And you need to think whether it makes sense or no. The example I gave you here, I use house price as dependent variable, and I see if I got more bedrooms and the house price will increase. I think it makes sense. And if you use survived as dependent variable, and I build the survived by age, for example, and then it doesn't make sense. I make calculation, say if I'm 20, then whether I would survive or no will be 0.7. So what does it mean by 0.7? Because I'm asking for a yes or no label or answer, and I don't need a 0.5 or 0.67 number, and I don't know what does it mean. So then in this case, it doesn't make sense for us to build a regression model on this variable called survived. So we'll need to pick a classification model. So that is another thing can help you to make the judgment, just to select a proper model. So basically that's it. That's what I would like to discuss. I have other slides just to summarize what we have learned. And at the end, I also gave you some guidance. I think I uploaded a template for the final project report. So basically, here's some guidance on how to write a report. And your third homework will help you work on the model part. And then when you trying to get your output into your written report, and you need to include some things. And usually we put the methodology and your result into one section. We just call the methodology and the result. And you need to discuss several things, including the model you picked and what the model is. So you just use several sentences and briefly explain the model. And explain your input output variables for the model and show your results for the model. And the result probably gonna be a table like for regression, and probably gonna be a decision tree, and probably gonna be your prediction accuracy. And all those things can be your results. And then after you show the result, either a table or specific number, you again need to describe the results. So add another paragraph using the plain English to describe your result. So what does it mean? And what is your interpretation on the result? And how can this result help you to answer your business question? And you can also evaluate saying whether the result is good or no. And we can just discuss a little bit on that. So those are the things you need to put on the report, and so how you convert the output from your Python script into a written report. So before you finish your final project report, you can take a look on these slides. Okay. So I think that's all I would like to discuss, and I hope it answers some of your question about your homework 3, part 1. And you can check my feedback and your grade if you still have questions on that. So just let me know. Okay. And then, there anyone have any question? No? No? Dependent variable is a Y for linear regression model. I'm gonna show you this one. Okay, right over here. So this equation, dependent variable is ticket fare. So it's a part on the left of the equal sign, and only one variable. And the independent variable are whatever you put on the right hand side. So in my case, I have 2 independent variables. We call it the X. And you can use X1 and X2 and to represent the number of parents and the P class. But those called independent variable. Okay. All right. So is there any other question? If no, you can just take a look on the feedback for part 1 and also work on the second and third part for your homework 3. And I can add them together as the your final grade for homework 3. Okay. And then next week we discussed on that. So next week I'm gonna give you a break. And probably gonna I'm gonna assign some reading task to you, but we'll not have a live class. And again, let me know if you like me to discuss something, and we can still do that. Or otherwise, we'll not have a class because that's Good Friday weekend. So I hope you can enjoy the whole weekend. And plus your holiday. I hope most of you have holiday, have the day off on Friday. So it's a small, long weekend. So I hope you enjoy that with your family, especially during this special period. So we will not have a live class next Saturday. And I will post another announcement just to remind you, you don't need to get up early and attend the class. Okay, but still let me know if you have any question on anything. And if no, I'm gonna finish all the gradings, and I think our due for the second part of homeworks tomorrow. I'm gonna check next week. So if you can submit it, just submit it by the end of this weekend. So I can give you feedback next week. If no, then I can definitely give you extension. You can submit it later next week. So just let me know if you need that, okay? All right, so that will be it for the lecture. Enjoy your weekend, and also enjoy your long weekend, and be safe, stay healthy.